This is the real Tom Rose, and we're being asked to solve for the range of values where this is true. Now, it starts as an inequality, and you can see that it's going to end as an inequality. But it starts with an absolute value and does not end with an absolute value. So in order to get to real numbers, we're going to need to neutralize this absolute value. One way to do that is to consider two hypothetical universes. There's the universe where 6x minus 5 is positive, and there's the universe where 6x minus 5 is negative. Right? In the universe where 6x minus 5 is positive, the absolute value sign does nothing at all. Right? The whole what an absolute value does, the whole purpose of it, is to take the stuff inside of it and make it positive. Right? So if it's a negative number, it strips away that negative and makes it a positive number. So when we're dealing with the universe where 6x minus 5 is already positive, the absolute value sign is doing nothing, which means you can simply rewrite this as 6x minus 5 is less than or equal to 8. Now we can solve for x, and we'll get one of our boundaries. So you'll get 6x is less than or equal to, right, add 5 to both sides, is less than or equal to 13. And you get x is less than or equal to, let's divide both sides by 6. Oh, what an annoying number. 13, x is less than or equal to 13 over 6. This is one of our boundaries. Now, in the universe where 6x minus 5 is negative, what does the absolute value sign do? Well, what it'll do is it will take, let's assume that number's negative. It will make it positive, meaning it will multiply it by -1. So in that universe, you can assume that -1 is being multiplied by 6x minus 5, and that all of that is less than or equal to 8. Now we can solve this. So let's divide by that -1, and you get, remember that when you're dealing with an inequality, if you divide both sides by a negative number, like this, you have to flip the sign. So we'll end up with a greater than or equal to -8, so which is 6x is greater than or equal to, add 5 to both sides, greater than or equal to 3, and x is greater than or equal to 3 over 6, which is the same as x is greater than or equal to 1/2. So now if we put this in order, 3, 6, 16, what we have is, let's take the smallest number on this. We want to build kind of a number line. So here we have 1/2 must be less than x, and x must be less than or equal to 13 over 6. So this is what we want to draw in algebraic terms. So you want to say something like 1/2 is less than or equal to x is less than or equal to 13 over 6. And search for that among your answer choices. Ooh, I left a negative out. Oh, and I just got saved by the answer choices. Do you see where I made my mistake? I had -8 plus 5. This should have been -3. -3, 6. This should be -1/2. Sorry about that. So we're looking for the answer. -1/2 is less than or equal to x is less than or equal to 13 over 6, which is that guy right there.